In this video, we will conclude our study of statistics by looking at linear correlation and regression. This is section 12.6 in our textbook, and I have selected an example to work through from the homework. And here's the example. This table that we're given shows the weights in hundreds of pounds for 6 selected cars. Also shown is their corresponding fuel efficiency in miles per gallon. What we are asked to do is use the data that's provided in this table to answer a series of questions. The first question asks us to determine the correlation coefficient. To calculate the correlation coefficient, we're going to use a formula. So we need to know what that formula is, and then we'll walk through the process of calculating that. But let's stop for just a minute and talk about what it means, what that correlation coefficient means. The correlation coefficient tells us about the relationship between these two studies. It tells us how closely related is the weight of the car to the car's fuel efficiency based on these 6 cars, which, do you notice that 6 cars really isn't that much? So we're going to have to see a very close similarity. We're going to have to see a very close relationship with there being only 6 cars in order to call it something significant. However, what we're looking for is how closely related are the weights to the fuel efficiency, and that's what the correlation coefficient is going to tell us. Here's the formula. It's just given to us in our book. But to use this formula, to apply this formula, we're going to want to be really comfortable with a few variables and symbols. Let's start with the x. We need to be able to determine which variable is x and which is y. So when we look at our table, we want to be able to determine which of is it the weight or the fuel efficiency that's independent, and then which is dependent. When we work this formula out, I'll be honest with you and say that it actually ends up not making a difference. So if you make an error in determining which is independent or dependent, it might not affect your coefficient. However, we do want to be precise, so let's work at connecting which is dependent and which is independent correctly. We'll also need to understand what N means. N means how many items were included in the study. In this case, we're told that there were 6 cars selected. So for this example, N will equal 6. And then lastly, this sigma symbol is a summation. So we'll need to understand that sigma means add up all of the whatever. So for example, when I see the summation of all x's, that's going to mean to add up all of the x's, or the summation of all of the x squareds. I'm going to find the square and add up all the squares, and so on. Let's talk a little bit more about which of our variables is x and which is y. To do that, we're trying to determine which is the dependent variable, which is the independent variable. We could ask this question: does the weight depend on fuel efficiency, or does the fuel efficiency depend on weight? What do we start with first? And that's the weight. The weight is what we started with. So the fuel efficiency depends on the weight. We started with the weight, so we could say that the fuel efficiency depends on. In other words, the fuel efficiency is the dependent variable. What's independent is going to be the weight of the cars. So what that tells us is our independent variable is always x. So the weight of the cars will be our x, our independent variable, and then the miles per gallon is going to be our y because it's the dependent variable. The fuel efficiency depends on, So the fuel efficiency is the dependent. Fuel efficiency depends on weight. Let's plot these numbers in. Now that we know that the weight is the x's and the fuel is the y's, I'm going to transfer the 26, 34, 35, and so on here into the chart for the x column, and then I'll do the same for the y's and fill in the chart with x's and y's. Once I fill in the chart with the x's and y's, I could do the x squared column and the y squared column. So the x squared column is 26 squared, 34 squared, and so on. The y column is 23 squared, and it looks like that one repeats. So we take each of our y's and square it. xy means multiply x times y. So 26 times 23, 34 times 23, and so on. 35 times 20. And that'll give us our product of x and y. When we finish that chart, feel free to pause the video and ensure that you are able to calculate each of the cells of this chart. You could also use Excel, by the way, if you're comfortable with Excel or some other technology. There's only 6 values here, so it's not terribly long to calculate. But if you find it helpful, feel free to use some other technology to calculate those numbers, because the next thing to do is going to be to calculate the sum. The sum of the x's is going to be 26 plus 34 plus 35 and so on, all the way down that x chart. The column for x's, add them all up to get the summation of the x's. Add up all the y's to get the summation of the y's, and so on. You'll see that I've done that sum, and I've written the numbers here to the left. I've also calculated that there were n cars, in this case 6 cars, so n will equal 6. I counted them out here in orange. 1, 2, 3, 4, 5, 6. So that's why n equals 6. Next, I'm simply going to insert those sums into our crazy formula. And you can see how I've done that here to the right. Let me break down for you how you could calculate this on your calculator. You'll want to practice this a few times, so make sure you're comfortable with this. And what I'm going to do is I'm going to calculate the top, and when I calculate the top I get negative 57. Once I get that numerator of negative 57, I'll do divided by, and then I'm going to put parenthesis and calculate the entire bottom, the entire denominator, and then I'm going to close the parenthesis to get that entire quotient. What we're seeing here with this formula, you could really think of it as being grouped together. A fraction bar acts like a grouping symbol. So we do the entire top, the entire numerator, and then divide that result, which was negative 57, divide the negative 57 by this entire bottom, or the entire denominator. So we'll put parentheses on each of those. Here's how you could use your calculator. If your calculator does the order of operations, I have a Texas Instrument 30X2S. That's the calculator I'm using. And for my calculator, it does, in fact, take in the order of operations. So what I'm going to type is 6 times 4,180 minus 189 times 133 equals, and I would get this negative 57 because my calculator does the order of operations. Check your calculator, ensure that you're getting the same result, and make sure that you know how to get that result with your calculator. For the denominator, I'm going to type in the square root. To get a square root on my calculator, I have to use the second function. So I'm going to hit second and then x squared, which gives me a square root. This parenthesis falls into place automatically on my calculator. When I type the square root, it automatically puts that first parenthesis. But then I'll type 6 times 6005 minus 189 squared. I could just type 189 times 189, or you might type in 189x squared, but then close the parenthesis so it knows that's what I'm taking the square root of. I'm doing the square root of this entire piece. Next, I'd hit times, and then I'm going to do my second square root. The square root, this parenthesis happens automatically. I would type in 6 times 2,959 minus 133 squared. So that's 133 times 133. Close the parenthesis, equals. And that should give me the end result of negative 402,197. And it goes on past that. But I'm going to round it to a negative 402 thousandths. Feel free to pause the video and practice with your calculator. Make sure that you're understanding where each of these numbers in the chart comes from, where each of these sums comes from, and where this coefficient for R comes from. Let's move on to the next part of this question. The next question is going to ask us to determine whether a correlation exists at alpha equals 1%. To do this, I'm going to need to pull out this chart. So on my math lab, you hit this information icon, the blue circle with an I, and when I hit that icon, this chart opens up. I can then use this chart to find when n is 6 and the alpha, or the level of significance I'm looking for, is 1%, I get a value of 91 7/10%. So what I'm trying to determine is whether my coefficient tells us that there's a significant relationship. If I take this absolute value of negative 402 thousandths, I'm going to get 402 thousandths. And I'm going to notice that that 402 thousandths is less than the value from the chart, the 917. So I can say that because this number is too small, because our 402 is too small, it doesn't make the cut, because it's 91.7%, or the 0.917, is like a cut score, determining whether or not there's a correlation that's statistically existing here. And we'd say no, because we don't make the cut. The 402 is too small of a relationship. Because it's too small of a relationship, we'd say there is not a correlation between the weight and the miles per gallon, not for this set of 6 cars. Again, if we had more cars, our level of significance would of 1%, our coefficient could have gotten smaller, and we would have still said that there was a linear correlation. But because we only have 6 cars, we need a pretty high percent, this 91.7%. So we'd say that no, a linear correlation does not exist. Let's look at this next part. Determine the equation of the line of best fit for the weight of a car and the fuel efficiency. To do this, we're going to use a formula for M given to us in our book. And for that, we'll need to go back to those values we collected and calculated on our chart. We could use M for the slope, and we could use this formula for B to calculate the Y-intercept. So we're going to calculate the slope and the y-intercept. This y equals mx plus b, as you may recall from algebra, is called the point slope form of a line. I'm sorry, not the point slope, the slope intercept form of the line, where m is the slope and b is the y-intercept. Applying these formulas, I'm going to get that the slope is negative 57 over 309, and rounding that to the nearest thousandth, I'd get negative 184 thousandths. Next, I can calculate b. And when I calculate b, oh, wait a minute. Do you notice this error alert? Do you see the problem, what I mean when I say I rounded too early? Do you remember that for slope, we got negative 57 over 309, but we estimated that at 184,000. So what I'm doing here is I'm going to round with something I've already rounded. It'd be a little more precise if instead I used this fraction, this exact answer, the negative 57 over 309, instead of the 184 thousandths, which I got by rounding. So let me recalculate this with that negative 57 over 309, our exact answer, and notice that our rounding is a lot happier now. We're more accurate. It's close, and for what we're doing, to be honest with you, my math lab would have accepted either of these two. But the second value is a little bit more precise because now we've used an exact value rather than a rounded value. Once we have our m and our b, we can fill those in to give the equation y equals negative 184 thousandths x plus 27 and 977 thousandths. And we could use that information to answer this question. We could use that equation to estimate fuel efficiency if a car weighs 3,300 pounds. In other words, I'm going to take our y equals equation, y equals negative 184 thousandths x plus 27 and 977 thousandths, and I'm going to replace that x with 33 for the 3,300 pounds, and I'd get that the fuel efficiency, y, comes to 21 and 905 thousandths. So what does that mean? It means that when the car weighs about 3,300 pounds, we'll get about 21 and 9/10 miles to the gallon when we're driving in the city. Let's look at one last piece here, even though the question doesn't ask us this. Do you see that we could graph our 6 points on an XY plane? And if I were to draw in a line that kind of draws all of these together, that line might look something like this. That line that I just estimated is our line of best fit, and it should match up to this equation. We can see that it is in fact decreasing because the slope is going downward, and we can see that it does hit our y-intercept of about 27.97. So that line of best fit is a good estimate. That's the last piece of how we can connect the data in a scatter plot to its best fit line. Well, I hope that you found this video walking through this example helpful. If you do have any further questions, please don't hesitate to contact me. I'm happy to work out more examples or to answer any questions you have about this topic. And thank you so much for the work you're doing and for making time to watch this video.